So in this video, we're going to look at something that are called periodic trends, and we're going to look at three different trends. We're going to look at trends in atomic size or atomic radius. We're going to look at trends in ionization energy, and we're going to look at trends in electronegativity. So by periodic trends, we mean patterns as we move different directions across the periodic table. So we're going to look at what happens as we move from left to right across the periodic table, and what happens as we move from top to bottom on the periodic table, to each of those three features of our atoms. But first, before we talk about that, I want to go through a quick review of atomic structure. So we know that our atoms have three subatomic particles. They have protons, they have neutrons, and they have electrons. In the middle of our atom, we have protons, and I'm going to draw our protons with pluses. Also in the nucleus, in the middle of our atom, we have neutrons, and I'm going to draw our neutrons with zeros because they're neutral and they have no charge. And then finally, we have our electrons, and according to the Bohr model of the atom, our electrons live in energy levels, and they fill from the inside to the outside of our energy levels. So our first energy level has 2 electrons. Our third energy level can have up to 8. And then that was our second energy level, and then our third energy level can have, how we're going to draw it, can have up to 8. Now, the third energy level can actually have up to 18, but just for our purposes, since we're not going to look at the transition metals, we're just going to look at the first 8 electrons that go in. Okay, so we're going to keep this in mind as we're looking at these trends. So when I look at this, if I have positives in the middle and negatives on the outside, if they're opposite charges, what do? Well, opposite charges attract. So our positives in the middle are going to attract our negative electrons on the outside. So all of our trends are based off of how strong those attractions are. As we move across the periodic table, what's happening to those charges? As we move from top to bottom, what's happening to those charges? How are the positives affecting the negatives on the outside? So the first trend that we're going to look at is atomic radius or atomic size. And just a quick definition, atomic radius is the distance from the nucleus to the valence electrons. And remember, our valence electrons are our outermost electrons. So this is the distance from the middle to the outside of an atom. The first trend we're going to look at is going from left to right across the periodic table. Okay, so if we think about what's happening as we start on this side, so lithium would be here, and then this would be lithium, and then this would be beryllium, and beryllium has 4 protons, and then boron, and then carbon, and then, carbon has 6, nitrogen has 7, oxygen has 8, fluorine has 9, and neon has 10. So as we're moving across our periodic table, our number of protons is going up. However, our electrons are all going into the same energy level. Okay, so as we move across our periodic table, if I have a model of our atom here, so they all have these 2 valence electrons, okay, and lithium has 3 protons. The next electron is going to go in the second energy level. As I move across, I'm going to add another proton, I'm going to add another electron, but it's going into the same energy level. I hit 5, add another proton, add another electron. Add another proton, add another electron. And this keeps going as we move across the periodic table. So every time we add a proton, we're adding an electron to the outside level. So what happens is we're getting more positive charge in the middle, we're getting more negative charge on the outside, but our negatives aren't getting any farther away. Now, if they're close and we're increasing the positive charge in the middle, those protons in the middle of the atom are going to pull on those electrons and pull them in closer. Since there's a greater positive charge in the middle, it's going to pull those electrons in, so our size as we go across is going to decrease. Not by a lot, but just by a little bit. And if you think about atoms, it doesn't take a whole lot since they're so tiny to decrease the size. So every time we move across, every time we add an electron, this energy level, this outside energy level, is actually getting a little bit closer to the center of the nucleus because those protons are pulling a little bit more on those electrons on the outside. As we move down our periodic table, as we go down, so our first here has 2 energy levels. As we go down, we now have 3 energy levels. And if we think about this as we go all the way down to the bottom, we're going to end up with 7, lost count, 1, 2, 3, 4, 5, 6, 7 energy levels. So as we go down and as we add those energy levels to the outside of our atom, our atomic size is going to increase. So as we go down, it doesn't have so much to do with that pull between the protons and the electrons because our electrons are getting farther and farther away. So the protons can't pull on the electrons because we're adding a layer every time we go down a row. So as we go from left to right, our atomic size is going to decrease because the protons are pulling on the electrons more as you move across. And as we go from top to bottom, our atomic size is going to increase because we're adding an energy level to the outside every time we move down a row. So that's the trend for atomic radius or size. Let's look at our next one. Our next trend is ionization energy. And let's give a quick definition to this term. So ionization energy is the amount of energy needed to remove an electron. And specifically, we're looking at removing the outer electron. So we're going to say needed to remove a valence electron. Now, if we keep in mind what's happening as we move from left to right, so we said the radius was getting smaller because the protons are pulling more on the electrons. Okay, so if my protons are pulling more on my electrons, it's going to require more energy to pull that electron away. So as we move from left to right, our ionization energy increases. If I think about it, if I have this marker and I'm holding it really tight, it's going to take somebody a lot of energy to be able to remove that marker from my hand. However, if I'm over here and I'm not holding onto it as tightly, it's not going to take as much energy to remove the marker from my hand. But as I hold it more tightly, as I hold it closer, it's going to get harder and therefore require more energy. As we move from top to bottom, it's the opposite. Our ionization energy is going to decrease. And this is because those electrons are getting farther away from the nucleus because we're adding an energy level each time we move down a row in the periodic table. So again, if I use my marker, if I'm holding it nice and close, it's going to take more energy to remove the marker. Whereas if I'm holding it way far away from me just by the tips of my fingers, it's not going to take that much energy to remove the marker away. So as we move from left to right, it's going to take more energy to remove an electron. And as we move from top to bottom, it's going to take less energy to remove an electron from an atom. Okay, let's look at our last periodic trend. The last trend that we're going to look at is called electronegativity. And electronegativity is a measure of the attraction between a nucleus and the electrons in a bond. So electronegativity is something that we look at specifically when atoms are involved in bonding. So when those electrons are being used to form bonds between two different atoms, that's when we're looking at electronegativity. And the electronegativity is really just how much is that nucleus pulling on the electrons in the bonds. So this is kind of similar to ionization energy, because it's how much, the higher the electronegativity, the more pull those protons have on the electrons. Which means as we go from left to right, our protons increase, but our electrons don't get farther away, our electronegativity is going to increase. Because as we get over to this side, these nuclei have lots of protons, but they don't have as many energy levels out from the nucleus. So these guys have the highest electronegativity. And then as we move from top to bottom, because we're adding energy levels to the outside and those electrons that are going to be involved in bonding are farther away from the nucleus, our electronegativity is going to decrease. So this is the same pattern as ionization energy. As you move from left to right, because the nucleus is gaining protons, but your electrons are not getting farther away, that nucleus is going to have a stronger pull on those valence electrons. As you're moving from top to bottom, your electrons in the bond are getting farther away from your nucleus, so it's not going to have as much of a pull on those electrons. So those are the three periodic trends that we're going to look at. Keep in mind, it's all about that relationship between the strength of the pull from the nucleus and where those electrons are.